Welcome to this explainer. You know the feeling, right? You're building or maintaining a web app, and keeping users reliably logged in while making sure they see the freshest content is basically job number one. But when things actually go wrong, the browser's storage mechanisms can feel like a total black box. Well, today, we are ripping that box wide open. We're going to solve some of the most frustrating session and caching bugs out there by absolutely mastering the Chrome DevTools Application tab. Let's dive in. Picture this. You get a ticket that just says, "User says they're logged out every time they refresh the page." It's a total classic. It is exactly the kind of vague, terrifying bug report that has haunted pretty much every web developer at some point. The backend team absolutely swears the API is sending the token, your front-end code looks spotless, yet the user's session just mysteriously vanishes into thin air. So, what's our first move? Instead of just blindly guessing, sprinkling console logs everywhere, or panic clearing our entire browser history, we need to open the DevTools Application panel. Just hit F12 or Ctrl-Shift-I. This panel right here is our primary magnifying glass. It's exactly how we inspect client-side storage, figure out background services, and nail down the real root cause of these super evasive bugs.
All right, suspect number one, the cookies panel.
The first place to look for a disappearing session is usually right under the storage section on the left. Click on Cookies, select your domain, and you are staring at the engine room of your app's identity management. You'll see a neat little grid showing the cookie's name, its value, and a bunch of super important configuration columns. Listen, an auth token's survival across page loads depends entirely on these specific columns. If even one flag is misconfigured by the server, the browser acts like a ruthless bouncer and just rejects your cookie outright. The absolute most crucial point here is the secure attribute. This little flag tells the browser, hey, this cookie must only ever be transmitted over an encrypted HTTPS connection. So if you've got a secure app, but your set cookie header forgets to include this secure flag on an HTTPS site, no way. Modern browsers will aggressively drop it, immediately breaking your entire authentication flow. But wait, there's more. You have to constantly check a few other heavy hitters. First up, HTTP only. If this is checked, client-side JavaScript literally cannot read the cookie, which is a massive, massive defense against cross-site scripting attacks. DevTools can see it, but malicious scripts cannot. Next is SameSite, which handles cross-site requests. Chrome actually enforces SameSite as lax by default now. That means if you're building, say, a cross-site widget and your cookie doesn't explicitly declare SameSite equals none along with that secure flag, it is going to fail silently. And finally, expires. If this just says session, that cookie completely dies the exact second the user closes their browser window. Moving down the sidebar, we hit suspect number 2, LocalStorage versus SessionStorage. These are super popular for storing UI preferences or temporary state, but you have to understand the stark contrast in their life cycles. Local storage persists indefinitely until someone manually clears it, but session storage, it is strictly bound to one specific browser tab. So, if you accidentally store a persistent authentication token in session storage, it practically guarantees the user will be logged out the moment they open a new tab or click a link that opens in a new window. Believe it or not, it's a super common architectural mistake. And hey, while we're poking around in web storage, keep an eye out for the dreaded quota exceeded error. Browsers usually cap these storage APIs at about 5 to 10 megabytes per origin. Try to stuff too much in there and boom, quota exceeded. Oh, and never underestimate the simplest, most maddening bug of all, a literal typo in your key names when calling getItem. Without a try-catch block or strict typing, that tiny typo can throw an unhandled promise rejection that completely takes down your app's state management.
Okay, let's pivot to suspect number 3, service workers and caching.
Yes, I clearly changed the code. Why didn't the page change? Users refresh, but the old UI is just staring right back at them. This nightmare happens because browsers aggressively cache service worker files to give you those lightning-fast offline experiences. A service worker is basically a programmable network proxy. If it's running a strict cache-first strategy, your users might literally be trapped getting served ancient HTML and JavaScript from a stale cache storage, completely oblivious to your shiny new deployment. So how do we break out of this cache hell? DevTools gives us a clear escape route. Head to Service Workers in the Application tab. See that Update on Reload box? Check it. That forces the browser to fetch the absolute freshest service worker script every single time you refresh. You can also manually hit Unregister or go down to the storage section and click Clear Site Data to just nuke the entire stubborn cache from orbit. Now pay really close attention to the status indicator here. If you see your service worker stuck in waiting, it means the browser successfully downloaded your fresh update, but it's flat out refusing to activate it. Why? Because the old version is still controlling tabs that are currently open. It will not activate until you step in and manually click Skip Waiting, or the user physically closes every single open tab for that app.
All right, we've gathered all our tools. Time for the climax. Live bug investigation. Let's put everything we just talked about to the test and actually catch this bug in the act. On one side, we have our symptom, the Jira ticket screaming about broken logins on refresh. On the other side, we have our diagnostic tool, perfectly focused on our active domain storage. So, thinking out loud here, let's trace the flow. Step 1, we log in and refresh the page to verify that, yep, we are getting kicked out. The state drops. Step 2, we instantly open the application panel, dive into cookies, and isolate our target. Let's call it the session ID cookie. Now we just audit those specific attribute flags.
Bango! There's our aha moment. Taking a close look at our session ID cookie, we see a totally blank space under the secure column, even though we're definitely running on HTTPS. On top of that, the expires column just says session, making it incredibly fragile. The token isn't surviving the refresh because the browser's strict security policies are actively dropping the non-secure cookie during the navigation.
Because we documented this exactly where it happened, we aren't just guessing. We can grab a screenshot of this misconfiguration, hand it to the back-end developer, and tell them exactly how to fix their set cookie headers. They add secure equals true, they set an explicit max age, and boom, the broken flow is completely resolved. Bug squashed.
So, bringing it all together, what's the big takeaway here? Mastering the application tab isn't just about fixing today's frustrating bugs. The web is rapidly moving toward the privacy sandbox, strict third-party cookie blocking, and heavily partitioned storage. The rules of client-side data are radically changing right under our feet. Using this panel to actively audit your cookies and service workers is absolutely crucial for preparing your web apps for the strict constraints of tomorrow. So the real question is your application truly storage aware? Get into DevTools and find out.